When we write our equations, we want to balance them. The balancing process is to show that we are not creating or destroying matter. We balance it so that we have the identical number of each atom of each element on both sides of the reaction, so we're not appearing to create or destroy matter. And the balancing process gives us information that we need to calculate relative quantities of the reactants and products. So when we balance it, now we're first going to start off making sure that we write our compounds correctly, and then we balance it by putting whole numbers, coefficients, in front of the compounds. So what that's saying is that we have more than one of those being consumed or more than one of those being reacted or produced. So when we balance our equations, our first step is to verify we have written everything correctly. Because if we don't have things written correctly, we cannot balance the equation properly, or if we appear to balance it properly, it won't be correct. So we first have to make sure we have written everything correct subscripts, and then once we have verified that, we are not going to touch our subscripts at that point. We're not going to touch our chemical formulas. We can't squeeze any numbers into the chemical formulas. All we can do is put numbers in front of them, which tells us that we have multiple of that compound participating in the reaction. We don't write the number 1. General rule, we don't write 1s. And it's usually good to start with the most complex formula. And what we're going to do is we're going to balance each element sequentially until we have balanced the whole equation. Although if we have a polyatomic ion like a sulfate or a nitrate, and it's showing up on both sides of the reaction, so it's not being destroyed in the reaction, we're able to balance that sulfate as a group, as a unit. Now, we can occasionally use fractions to balance our reaction, and usually we only do that if we have everything balanced except for one element, and we can balance it using a fraction. And then that'll give us a balanced equation, and we just multiply the whole equation by the denominator to get rid of the fraction. We generally don't want fractions in our balanced equation. We do it at times when we are doing a specific process to the equation. So we balance one element at a time. We keep repeating until we have done all the elements and everything is balanced. But as we balance the second or third element, we might unbalance the first. So after we think we have everything balanced, we go through and we verify that everything is balanced. So some examples. So if we react cobalt with hydrochloric acid, the cobalt metal will dissolve, forming cobalt chloride, and the process will bubble out hydrogen gas. So we write down the equation. Cobalt plus hydrochloride yields cobalt chloride plus hydrogen gas. Now we check to see if it's balanced. We have the same number of cobalts on both sides, but we don't have the same number of hydrogens on both sides. We have a subscript 2 on the right, 2 hydrogens on the right. We have 1 on the left, so on the left we put a 2 in front of the hydrochloric acid. Can't change the subscripts. So we put a 2 in front of the hydrochloric acid. So we're doubling the hydrogen and we're doubling the chloride, so that 2 multiplies everything in the compound. But by doubling the chloride, that actually balanced it, because we had a 2 subscript on the right, and now by putting a 2 coefficient in front of the hydrochloric acid, we have 2 chlorides on the left also. So another reaction, if we have aluminum oxide react with chlorine gas, that'll give us aluminum chloride and oxygen gas. So we write the compounds first, make sure we have aluminum oxide is correct, Al2O3, chlorine is diatomic, oxygen is diatomic, aluminum chloride AlCl3. Once we confirm that the reactants and products are written correctly, now we can balance it. Let's see here. We look at the what's the best thing to start on this one? We scan through. We see that there's 2 aluminums on the left, 1 on the right. We could do that one easy. The harder ones are going to be the oxygen. Oxygen is 3 on the left, 2 on the right. Chlorine, 2 on the left, 3 on the right. So those 2s and 3s, they are a little bit harder than the aluminum. So if we take that chlorine, there's 2 on the left, 3 on the right. So 2 cannot divide into 3. 3 cannot divide into 2, so we go for the common factor. 2 times 3 equals 6. So if we do that, we would put a 2 in front of the aluminum chloride and a 3 in front of the chlorine. Do a similar process with the oxygen. Again, we have this 2 and the 3. So to find the common factor there is going to be 2 times 3 is 6 again. So that means you put a 2 in front of the aluminum oxide and a 3 in front of the oxygen. So we balance chlorine, we balance oxygen, we check the aluminum. We stuck a 2 in front of the aluminum, but that's 2 times the subscript 2 is 4 aluminum. On the aluminum chloride, we stuck a 2 in front of that also, but there's no subscript, so we only have 2 aluminums, so the aluminums aren't balanced. And so we have 4 on the left, 2 on the right, so we have to multiply the right side by 2 again, turning that into 4. That will balance our aluminum but unbalance the chlorine. So we double what we had on the chlorine. We had a 3, and multiply by 2 again. That gives us 6. So that gives us the final balance equation on the bottom. 2 aluminum oxides plus 6 chlorine gases gives us 4 aluminum chlorides plus 3 oxygen. So it can take quite a few molecules or formula units of individual reactants to produce the product, and in the process produce quite a few products, each of the products also. Okay, so if we react nitrogen with oxygen under high pressure, we can get dinitrogen pentoxide. So we look at this, the nitrogen is already balanced, N2, N2, but the oxygen isn't. We have a O5 and an O2. So common factor there is going to be 10. So we're going to multiply our O2 by 5 and our N2O5 by 2. By doing that, our oxygen is balanced, but now we have unbalanced the nitrogen. So to balance the nitrogen, we need a 2 in front of the reactant nitrogen, and now we have a balanced equation. We're going to give a couple introductory types of reactions here, chemical reactions. If we take 2 reactants and end up with 1 product, we are combining the 2 reactants together to form 1 product. This is a combination reaction. Some authors call this a synthesis reaction. That's not the best term, because in labs, chemists call synthesis reactions when we are producing a particular product, but it might take many steps and it might not look anything like this combination reaction. If we start off with 1 reactant and make 2 products, 2 or more products, we are decomposing something, so that's a decomposition reaction. One very important reaction for our society, we live on it, is combustion reaction. Combustion reaction is a rapid oxidation reaction that produces heat and light. So it's a very exothermic reaction, and we use that heat that it releases, that energy it releases, to warm our houses, cook our food, drive our cars, make electricity. We live on this combustion reaction. And we are usually burning hydrocarbons, compounds that contain carbon and hydrogen, although other things can burn also. We can even burn metals.